here, grab your TIs, and let's learn how to never ever do that calculation again. Yes! Oh, hell yeah! I mean, I do not care. I am not here to test you on arithmetic. I am not. And please understand why I made you do that arithmetic. I needed you to see that the sum of the deviations was 0, and I needed you to see how we dealt with that. Now that you know, you never have to do that again. Good Lord. Good Lord, no. But you, Christina, we have to know what it means. That's the crucial thing for me. When you guys read your journals and your psych and your soc and your HDFS classes, they're not going to make you calculate that crap. It's already going to be in the journal. You need to know what it means when you see it in the journal. That's what I'm after. Okay, here's what I want us to do. Fire these bad boys up. Let's make sure we can see this okay in the screen. It's a little small. Zoom in. Good. That's a good zoom. Yeah. Okay.
We're doing Bert, right?
Say that again?
We're doing Bert.
We're going to do both Ernie and Bert at the same time. Well, not at the same time. We'll zoom sequentially. So first thing you do, get familiar with your stat button. Find it. Stat. Mine's under the DEL button above the PRGM button. To the left of apps, to the right of apps, to the left of bars. Press it. Please. Press the wrong button. There we go. This is your stat menu. I'm assuming you have a TI-83 or a TI-84 at this point. So if you don't, we can figure this out after class. Happily. Edit. Now, I've got stuff in my lists because I wrote a program for 105 that used it. So, does anybody else have stuff in their lists? Some of you do. Fantastic. If you don't, pay attention because this is how you get stuff out of your lists. Put your blinker up on top of whatever list name you want to get the stuff out of. So mine is L1. Find the clear button and press clear and then press down. And that'll wipe out all the data. Do the same thing. You clear out L1 and L2 for me, if you'd be so kind. Clear that. Whoops. Oh, I hit the wrong button. There we go. There we go. What you don't want to press, is anybody missing L1 and L2 right now? It's easy to delete them. If that ever happens, don't freak. Just email me and I'll tell you how to get them back. It's easy little two-step move. Or Google it. It's probably even easier than emailing me. Cool so far? Do this for me. Put Ernie's test scores in L1 and put Bert's in L2. So Ernie's, if I remember correctly, actually I don't remember anything, they're right here. He was like 70, and order is completely irrelevant. It doesn't matter what order you put them in, the TI doesn't care. The standard deviation and average formulas are full of addition and multiplication, and those are commutative. So it doesn't matter what order you do those things in, so you're solid. Bert's, I'm getting 61. That's 68, I think. 82. 94, yes ma'am. And you got that 100, didn't you, Stacy? Awesome. And again, it doesn't matter to me what order they're in, completely irrelevant. Doesn't matter to me whatsoever. Doesn't matter at all. Oh. Okay, now, this is editing data. Your data is now in. Press your stat button again. Now, the other parts of this, boom, 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 these are all great, and we'll deal with those in time. They're all very useful, but we're not going to deal with them right now. The menu I want to check out is the Calc menu next. So use your arrow key to go over 1.
Oh, wait. Darn it.
Just press that.
Okay.
You're back here, then press the right arrow key over 1. You got it, my friend, you got it. Now, there's a lot of stuff in here, and in 105 we actually used quite a bit of the stuff below, with lin reg, quad reg, exp reg. We're not going to use any of this stuff in this class, except for the very first one, which is called 1 var stats. What do you think var stands for? Variable, believe it or not. It stands for variable. Variable, and the reason it's called 1 variable statistics is because there's only one variable for Bert and Ernie. It's X, which exactly, Patrick, it's X, which is their exam scores. That's the data. They vary. Two variable statistics is very important. We'll deal with it in 244. That's when you have an X and a Y. When I told you guys, on average, the more quizzes people do, the higher their overall grades are. That's two variable statistics. Two variables, their quiz numbers they turned in plus their grades. We'll do that in 244. Bivariate data is awesome, I love it. But 243, univariate data. Grab it! When I say grab it, press enter, sorry. or one, either the, yeah, you got it.
That is not what my screen looks like. I have a TV.
Oh, yes, if you have a TI, do you want it to look like this?
What?
I can make it look like
Oh,
this
no,
if you
I don't
want.
care.
Okay,
I'm good.
okay.
I'll get there.
Does anybody's screen look a little bit different than this? The newer 84s have a stat, I think it's called a stat, what the hell's it called? Stat something or other. No, it's got a fancy name like stat something clever that I can't think of right now. So that's okay. You can turn it off and turn it on if you get tired of Stacy. So everybody's looking like this pretty much? Press enter. There's a lot of stuff right there. But good. That's the sound I like to hear because that's the sound of, oh my God. I no longer have to add a bunch of stuff up anymore and divide by 5 because it just did it for me. Do you see what it did?
Oh, it did all those things.
Look at that.
Made us do again. Oh, you're evil.
I'm evil. I am. What's this?
It's the sum of the first total.
Yes, that's the total of the exam points. Sum of x, which is the 405 total points. This is Ernie, right? This is Ernie. What's this?
The sum of x squared.
Right. That's another sum of squares, but that's, I don't even know why it's included anymore.
Then it's unsquared.
Does this look familiar? That's who we love. That's what you just had to do by hand. But now, there it is, to 10 decimals if you need it, which you'll never need. 2 is probably plenty. Now, look right below that. See this guy right here? I want to make a quick mention of him before we go any further. A quick mention of him before we go any further. I'll put it over here on the sideboard and we'll clear this out. And Danny, what you said about the plus or minus is so crucial. We'll get to it on Wednesday, I promise you. And I like this chart because it kind of points us to that direction. Okay, little 2x2 table, contingency table, as you guys are learning from your first project. Both a sample and a population have an average and have a standard deviation. Kind of run. Like sun layer. What's your sample average symbol? What's your sample average's symbol? We've used it a couple of times today already. What's the symbol for it? X bar. Yes. X bar. And we easily have, you can't see that again, Christina. Thank you for looking up and thank you. It's a shame my dance didn't get caught on camera. Oh well. What's the sample standard deviations letter? We just learned it. I just erased it with my hand, actually. It's S. Your TI calls it S sub X, and that's okay. It's just S in general. The reason it's S sub X is because it's referring back to the variable they're calling X. You don't have to do that if you don't want to. Just S. Or S sub X. I take either one. But in the general literature, it's just little s. Fair so far? Good. In the population, these exist as well. In the population, the average, did I mention this in class? I may have. Mu, the Greek letter mu. That little guy. It's like a little U with a tail, mu. And the reason it's mu is because average, the technical phrase is mean, and that's the same sound, mean. That's totally fine. I probably am drawing it incorrectly. And we never talk about it. I shouldn't say never. We very rarely talk about it because, well, not so much who cares. I care about it.
Sorry.
I care about it, but why don't I talk about it very much? At least not till 244 or more. It's not what? Why is it not relevant? What is the population average age of everyone in the United States? Could I ever know it? Why? Because in the time I've just asked you, somebody died and 2 more were born. Oh, and look at that, somebody else just died. Oh, look at that, somebody else was just born. It's constantly changing, and even if it weren't changing, what kind of a daunting task would it be to go average 310 million people? So, I love the fact that it's there, I am interested in it. I'm never going to know it though. So instead, I get a sample average. And I apply, Danny, a plus or minus around that to give what's called a confidence interval. This is what the next 8 weeks are all about, really, is developing this idea. Good. The population also has a standard deviation. Guess what it's called? It's that little guy right there. It's lowercase sigma. It's lowercase, that's what the small s sound is. The big S, the big sigma means to add a bunch of stuff up. That's big sigma. Add. That's lowercase sigma. They look so different from each other. It's kind of crazy. So every once in a while you'll see a little tiny, like a sideways number 6. That's lowercase sigma, and I think it's sigma because of standard deviation. They use the same sound. Whoops. There we go. You are never going to use this number on your TIs. I wish I could turn it off personally. Because you never, what's the implication?
That to the whole population, 1.41 is the deviation.
Exactly. Exactly. Now, from a computational standpoint, it's similar in computation to the standard deviation, the sample standard deviation, except you actually do divide by the entire population. But that's an asinine statement to even think about, because you never know what your true population is.
Why do they have it in there?
I don't know.
Okay.
I don't know. It's a damn good question, Tiffany. If I could rewrite this, I would take out a couple lines. I would also remove that and just leave the same. But it's not mine
Bring
to
it out of the
rewrite.
80s.
Say that again?
And bring it out of the 80s.
And bring it out of the 80s. Maybe add some color. You know. So this is kind of where we're at. We are interested in these values,
Right.
but these are the ones we're allowed to have. So and plus or minus is coming. That's Wednesday. Now I want to swing back to the TI screen. Do you see that little arrow at the bottom? It's also telling you that n equals 5, but you knew that. There's 5 data points. 5. There's my phone. Now scroll down. It gives you a few other things. The numbers down here are called the 5-number summary. We'll come back to that on Wednesday. I promise you on Wednesday we'll come back to that. It gives you the min value of 79. It gives you the median of 81. Boom. No longer do we have to chop, 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 chop. Oh, that was fun, Shayna. That was fun doing earlier. But we don't have to do it anymore. Now you just look at it this way. Gives you these guys. We'll deal with these guys on Wednesday. And it gives you your large value. And again, this is a little silly because there are only 5 data points. This gets very handy when there are thousands of them in a histogram, in a distribution. Very, 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 very handy. Cool so far? It doesn't give you what? There's one thing it doesn't give you. It doesn't give you your mode. But you can write a program for that, but it's honestly easier just to kind of look through it. We'll deal with that. We'll deal with that later. Okay so far? Yeah, you can go just arrow down. Use your down arrow and scroll up and down. There you go. Up and then back down again. So this is Ernie. Now, when I was interested in Bert as well, I said, what do you think Bert's, well, we had some great values. We had 6, 20, 15. What is Bert's standard deviation? So here's how we get Bert. Press the stat button. Press the stat button. Remember, now you already entered Bert's data in, remember?
Yeah.
You put it in L2. Arrow over to Calc. Press enter. Now, you have to tell it L2. When we pressed L1 before, or we pressed enter before, it immediately went and looked at L1. And it will do that by default. If your data is anywhere else, you have to tell it where it is. So you tell it L2 by pressing second and the number 2. Second and the number 2. I think yours, you got it. You got it. You got it. Tell it what you're supposed to look at. This will now look at L2 and ignore L1, which is exactly what you want, right? Let's do it. Enter. What the hell? It looks just like Ernie's. Oh, wait. Some of it was the same, right? Some of it was the same. Notice how his average is the same. But we knew that. We calculated that before. Is the sum of x, does that looks to be 405, that looks to be the same as Ernie. It has to be. If his average is the same, that means they have the same number of points. Fair? Does this look the same?
Yeah.
This is where it starts getting different. This is the sum of the squared test scores, which is meaningless to us, so don't have to worry about that. This is what I care about. Bert is about 16.5 for his standard deviation. What does that mean about Bert? Close to 20?
Not very consistent.
Not very consistent. Give it to me in words. They put it in a sentence for me. I'll get you started. On average,
Bird scores are about 16.58 points away from his average.
on average, Bert's scores are about 16.5 points away from his average score of 81. I love it. I love it. That's essentially what a standard deviation is. It's a measure of how far you are from your average on average. So it's doing, if you will, it states the same thing that your measure did, your average deviation, that's the pure average distance on average. But this one is the one that gets used in conversation. And go scroll down, you see the rest of them. There's his median of 82. There's his min and his max of 61 and 100 and so forth and so on. This is what standard deviation gives us. I do not care to watch you guys suffer through the calculation of a standard deviation. I do not care to see you suffer through the calculation of a standard deviation. It's ridiculous. It's pointless. It doesn't make any sense. Here's what I need you to take away from standard deviation for today before we come back on Wednesday, okay? Here's the big takeaway. First of all, takeaway. I think that's right. On standard deviation. Now, just so you know, the topic is called variation, or variation in data, or something along those lines. It's how data varies. Whereas measures of center is how data collapses to a central value. Variation is paired with that because it tells us how the data interplays with that central value. Big takeaway. The definition of standard deviation, okay? Make sure that you can say, on average, data is blah, and that blah is the value of S, whatever that number is. On average, data is blah, points, I'll just put away from the mean.
Or the average.
Or the average. Or the average. Yep.
I want the average.
That's cool. That's cool.
Thank you.
I tried pedagogically to keep sneaking the other words in there. Mean, average, mean. No, but I want to because when you guys read journals, when you're sitting there in your HDFS class or your natural resources class or your social class, you're going to see both those phrases pop up, and I'd rather prepare you for that. So when you hear the word mean, it means average. When you hear the word average, it means mean. And when you hear both of those, it means add everything up and divide by n. X bar, same thing. So that's the one big takeaway. The other big takeaway for today, and we're going to explore the plus or minus more on Wednesday, is quote unquote big S values imply that the data is doing what? Or the data is what? If you have a big, now I am purposely putting big in quotes, Jared, I'm thinking of you. Because when you said better, how do you define better? How do I define big? We'll come back to that on Wednesday, I promise you. But big S values imply what about the data? Say that again. Excellent, Tiffany. Inconsistent data. Data is inconsistent, spread out, something that implies that the data is not centered tightly. Back this out a little tiny bit. There we go. Something that implies the data is not centered tightly around a center value. Because the idea is the S standard deviation value, this beautiful little thing we just calculated today, is centered around the average. But if it's wide, if it's a wide value, if it's a big value, that means it's like buckshot spread out around that average. The average is still in the middle, but it's all over the place around it. So a small, in quotes, a small S value means the data is what? Good, I like consistent. If you had to use a non-mathematical or some other word, what would you use to describe the consistency of the data?
They're close.
Close! Close to X bar, put that in there maybe. Close to X bar, close to that sample average. And we're using very relative word, I'm using the word close. Inconsistent, big, small. Nobody argues that Bert's S value is bigger than Ernie's. As a matter of fact, it's about 10 times as big, isn't it? Right? Which kind of goes, holy crap, that goes really nice with your range, Heidi. Your range was 40 to 4, which is a 10 times different. His standard deviation is roughly 10 times Ernie's. Nice, very nice. So, we can look at Bert and Ernie and say, okay, obviously Bert's more inconsistent than Ernie. It's 10 times the standard deviation. But if you had Bert by himself, without Ernie for reference, it's kind of hard to kind of compare those two things. More on that on Wednesday, I promise. Stacy, go.
The sample size, because when we're putting
Yes.
it in here, it's only this average of that person's data,
Exactly.
not both.
That's 100% true.
Okay.
I'm not going to cross-reference those.
Okay.
We're going to compare them apples to apples, but as soon as you cross-reference them, you're basically doing what's called a matched pair analysis, where you're trying to pair up one data point with the other one. And in that case, you'd have to actually pair like first exam, second exam, second exam. I need more information than I actually have.
Okay, so.
You do want that sometime, don't you?
Yeah, like their average wasn't the same, so we'd be talking about something totally different.
But possibly. Well, no, you can still talk about standard deviation. This goes back, Walter, thank you. This goes back to Walter's question. Suppose you were interested, and this is actually part of this topic, which we'll get back into, the idea of margin of error. If you were interested in seeing if Obama's approval rating right now is lower than it was 3 months ago, you could check Gallup 3 months ago and look at what the percentage was, and look at Gallup now and see what, you know what the hell are we talking about this? Let's do it. Why are we talking about this? Let's do it. I was going to let you know how about